Yo, what is up, guys? Welcome back. Uh, another day, another video. I'm on the Linux boot here today, so Planet is probably going to do a problem or two. My headset's about to die though, so that's not good. So we're probably going to keep going until my headset dies. I don't know how long it has left, and I don't have the software installed to check. It's just telling me it's on low battery. So, yeah. So we're just going to see how long we end up going for. So, yeah, type shit. Take a look at some problems today. Ethan mentioned I should do another data structure problem.
Yeah.
Oh, you're back. What's up?
Yeah, what's up?
Power 3. Should I quickly do the daily problem then? It's an easy problem. Give an integer and return true if it's power 3, otherwise return false. An integer 3 is power 3, there exists an integer such that. Set this up. I'll do this problem, then I'll do a data structure problem. Shouldn't take too long.
You want to share your screen?
Oh shit, yeah. And I got my M.2 today in the mail, so W's. It's gonna be fire. Now I'm not gonna have 256 gigabytes in my Windows boot, and I can actually play games too. So let's go. It's a W.
Do it in C++.
Yeah, I will. Okay. Integer n return true if it's power 3, otherwise return false. Integer n is power 3 if there exists an integer x such that n is equal to 3x. N is equal to 27. 27 is equal to 3 cubed. Okay. I feel like this is a simple problem, but is there a simple check for... Or are we given an integer n? We're given n is equal to 27. Check for power 3. I'm not sure. I feel like there's a simple check with a modulo or something, or I don't know. Maybe maybe have to be a recursive function here. I'm trying to check. Repeatedly divide by 3 until it becomes 1, ensuring it always divisible by 3.
Yeah.
Wow. Wow. Can't we just do %3 is equal to 0? Or no? Would that not work? Like, wouldn't that just give us the remainder and then we would know that it's divisible by 3? I don't know, or is that way too simple?
So wait, you're saying just to take n and 3?
No. Yeah, n%3 is equal to 0. Because then we know that it's like fully divisible by 3. But then that probably wouldn't work because then you'd have like... You could have like 6, and that's not a power of 3, right?
Right.
So that wouldn't work, yeah. Anyway. If n is less than or equal to 0. While n is greater than equal to while n is greater than or equal to 0. We just return false. If n, oh, we need brackets, parentheses around this. If n is equal to 1, we...
Well, I think the outer loop, you want to check if it's, like, if in mod 3 is equal to 0.
You talking about the while loop, or
Yeah.
if n mod 3?
Because then you're checking if it's divisible by 3.
Okay. Okay.
And then you just divide, in the loop, you just divide by 3. Like, n divided by equals 3.
Okay. So while n mod 3 is equal to 0, n divided by 3. And then we check.
You don't need that in there.
Sorry, what'd you say? You talking about these if statements, so what'd you say?
Yeah, you don't need those if statements in there.
Roy Leetcode. What's up, bro? Have you gotten a job yet? No, I have not. I haven't started applying yet. So, no. Not yet. Sorry, you were saying the if statements, dude?
Yeah, you don't need them in there. Because now, like, after the loop, n's going to be either equal to 0 or 1.
Yeah,
Right.
yeah. Love the dedication to CPP. Thanks, bro. It's a grind.
So n's a power of 3 if it's equal to 1 at the end of the loop.
TLE.
Oh, you have to check if at the before the loop, you have to check if n is equal to 0, because that'll just always, and 0 divided by 3 will just be 0, and 0
What, inside the
mod
loop or
3
outside?
No, outside the loop. If n is equal to 0, you return false.
Dedication CPP, bro. Here we go. Okay, I was thinking about it in a different way. I guess the way I was gonna do it. I mean, having.
How are you gonna do it?
Well, I don't know if mine would have worked, but maybe I would have got to the solution. But having the if statements inside the while loop, and dividing n every single time. What was my while statement before? It was n is greater than
or equal
0.
to 0.
Yeah, and just keep dividing n. But I don't know. Would that have worked or probably not? Like, maybe. I don't know. I didn't really.
I mean, there's only one. You could test it.
Could you do this by dividing by... Question reminds me of Fizzbuzz, sort of. Yes, sir. Also, just realized you use Mint. Yeah, I have multiple. I use. I'm not familiar with Linux. I mean, I'm okay with it, but like, I'm not like a Linux pro at all. But I do a bit. I just like to try out Linux and try out stuff. But yeah, it's fun. It's a good time. It's kind of vague sometimes, but oh, this is 0. Okay, so if n is equal to 1, turn false. If inside the loop here we do n divide equal to 3, then oh shit, dude. Maybe if n percent 3 does not equal 0. With 0, what we would return false. Otherwise, we would return true. Nope. If that is equal to 1, return false. And divide by 3. Yeah, your solution is definitely way better, bro. I'm fucking up something here. Dividing through every single loop. If n is 1. Okay, this has to be false. It's not divisible by 3, we return false. If n is 1, we return true. N is 1. Maybe we return true here. Because if n is 1, we would return true. So then maybe what out here we would always return false. TLE. Let's go. What was the... What did you have outside of here that fixed the TLE?
Well, just like if it was 0, return false. I mean, you could just... I think you could fix that just...
Less than or equal to
by...
0?
No, you just could remove the equal sign in your while loop, I think. You don't, and then you don't need that if statement anymore.
Bruh.
Nice.
Let's go.
There we go. Good job.
Okay. You got a data structure problem, bro? Data structure problems on Leetcode. Problems to design data structure. Problems to design data structure. Code. Maybe you can search by the problem design data structure or something.
I think you probably can.
What's up, llama, dude? Filter by topic. I think they're called design. Yeah, I think that's what they call.
Ooh, do the LRU cache. Do that one.
Succeeds. Design a data structure that follows constraints or at least recently used LRU cache. Implement LRU cache class.
So, do you know what an LRU cache is?
I know what a cache is. Maybe not specific. It's familiar, but I'd have to refamiliarize myself with it.
So all it is, like LRU stands for least recently used, right?
Yeah.
So it has a capacity. In capacity, you see that in the constructor.
Yeah.
So whenever you're like adding an item to the cache,
Yeah.
it will, if the current size of the data, like let's say the capacity is 10 and you haven't added anything. So the capacity is 10 and the size is 0, right?
Yeah.
When you add something to it, the size will increase. Well, if you add something to it and the size would go over the capacity, instead of just adding it, it will first remove the least recently used element in the cache.
Yeah.
So that's how it works.
Okay. LRU cache. I'm gonna get AI to explain it to me as well. Ooh. Let's take a look. I'll put this on the screen. Stores a limited number of items that have extra items. put cache 100. Turns 100, moves 1 to front. Okay, so with the... So you want to get a specific item from the LRU cache, right? When you get the item, you retrieve that item, but then you move it to the front. That's what you said?
Well, I mean, what do you mean? Like, do you understand what it's saying? It's saying these two data structures.
Yeah, I saw that here, but I'm kind of reading more of the example where they put, I mean, they have a capacity of 2. They put 100 in the cache, and they put 200 in the cache. Then they get 1, right? So it returns 100, but then moves it to the front.
Right, because it was the most recently used.
Most recently used. Then they have the put function, right? And the put function puts it in there as long as it hasn't reached the capacity. But if the capacity's been reached, then it removes the least recently used one, which in this case was 2, because 2 hadn't been accessed in the longest time.
And what's the capacity?
For this example, the capacity is 2. But
right, so that's why it removes it whenever it adds a third element.
Yeah. Yeah. Okay.
Yeah. And you can see that whenever something's put into the LRE cache, it goes to the front of the most recently used list.
Yeah. 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 Okay. Goes to the front of the most recently used list. Yeah. Okay. The key exists, update the value, move to the front, else insert at the front, and if overcapacity, remove from the back. Okay. Okay. Okay, so first of all, I guess we probably want to create our hash map, right? So m underscore I guess we can just call it items. Ordered map. What are we working with here? All integers, so int underscore items.
I would start with just getting the map working.
Yeah,
You know?
yeah, that's what I'm thinking.
Okay.
So how do we want the map to work?
Just some tips. You're going to also need to store the capacity as a member variable. You want to do m underscore capacity. And then set it in the initializer list on the constructor, because that's where it's being passed in. So remember, don't do it there. You want to use the colon after the constructor.
The colon after the instructor.
So go to line 3 and go before the curly brace.
Okay. And initialize it here?
No, you're not understanding. Go on line 5 now. And go before the curly brace.
Oh,
what if-
okay. I think I know what you're talking about, actually. Hang on. You did teach me about this. Hang on. I just don't remember the syntax here. Hang on. Let me think about it. It's a colon initialization, right?
Yeah.
Yeah, just hang on. Let me think about it. I remember. I need to remember how to do it. Is it? Hang on. M underscore capacity. Capacity? Is that right?
Yes.
Okay. Sweet. Okay. But we could have just done this within the brackets, right? Too?
You don't want to do that though.
And what's the reason again?
Do you remember?
I don't know the reason why. I can't remember.
So, okay. So the reason is because whenever you do it, okay. So if you do it in the colon, right? Like in the, it's called the initializer list.
Yeah.
If you do it there, it's going to, when m underscore capacity is constructed, it will construct it with the value of capacity. Otherwise, it'll construct it with the value of 0, and then it will go inside the curly braces, and then you set it to be capacity. So it's just the difference between setting it once and setting it twice.
So it's just like a little bit of performance based? Is that why?
Yes.
Okay.
And that's like how you should do it. Unless you have a good reason to like put it inside of an if statement or something like that. But in this case, you don't.
That shit throws me off. Okay.
Well, you could write it down again, I guess. Does that help? Was that helping?
Yeah. No, yeah, it is. I'm gonna write it down. Hang on. Gotta get my microphone out of the way, bro. Okay. Okay, the colon initializer directly constructs. So I'm writing the colon initializer. It directly constructs directly constructs the members first, rather than I'm gonna say rather than initializing them and then assigning them a new value inside the brackets. Is that correct? Or
Yeah, because it'll default construct them, and then you initialize them if you do it inside the brackets.
but instead the colon initializes it all once.
Yeah,
One
it
sitting instead of
directly
doing it twice.
construct. Yeah, it explicitly constructs it with the value that you pass in the first time.
Okay. Cool.
So what are you thinking about?
Um, Let me think. Okay, so get in key, return the value of the key if the key exists, otherwise return -1. I mean, well, right now I feel like, I mean, I'm just thinking like pretty basic here right now for the get, like, what, just initializing a hash map and grabbing the value if it's there, and then if not,
So yeah, you should start input,
okay.
right? So input, what does put need to do?
But just puts the value in there. Update the value of the key if the key exists, otherwise add the key value pair to the cache. And then we had one more thing where we had to we put it, okay, so that's for get. So for put, we'd put it in at the front, right? Or
Right, but you're not concerned about that because you can't do that in a map. A map doesn't maintain
Yeah,
ordering.
yeah.
You're going to need a second data structure for that. But for now, you just want to get the map working.
all right. So we can start with put if the key exists. So loop through the map and check if the key exists. So what we'd probably have to use iterator in C++. Okay. Well, masquerade items up again. Masquerade items end. Yep.
That's not what you should. I wouldn't do it that way. 'Cause do you remember the find function on a map?
Yeah, why won't we do it this way? Is this a bad way to do it, or just a slow way, or you said just check with just what the find function?
Yeah, so you want to do if m underscore. Well, here I can tell you.
Okay, what is it? M underscore items dot find.
Yeah, and then the key does not equal cache dot end.
It's not equal. What'd you say? Cache dot what? You said cache?
So you named
What did you say?
Yeah. Your items, the cache.
Oh, okay. Dot end. Oops.
You should make the code window bigger. You don't need to see the problem. But you could move it on the left so you could make the problem itself smaller. Yeah.
What, like this?
Yeah. All right, cool. So, yeah, so now, right, you know that it exists. Right? So you just update it.
M underscore items key is equal to value?
Yeah. And then you can just return.
Return the value of the key. Return. So
Yeah.
store it in a variable, or you think, or
Why would you store it in a variable?
or would I just return what this?
What is the function? No, you're Max. What is the function returning?
Returning the key. Return the value of the key. So what?
That's the get function.
Oh shit! Is that the
Where-
get function? Oh shit! Whoops. Okay.
It just returns void.
Update the value of the key if the key exists. Otherwise, add the key value paid to the cache if the number of keys exceeds the capacity. Oh, it's void. Okay. All right. So what? I just return.
So you just return.
Shit,
yeah.
My bad.
And then
the fucking get one. Whoops.
And then now outside of the if statement, you just add it. Well, so we're doing it this way so that it's easier for you whenever you add the LRU behavior. But so add a comment here that says, like, if we're at capacity, evict the least recently used.
Least recently used.
And then now go under this comment and just say pretty much exactly what you have on line 18. You don't need a comment. Okay. So this is like, that's where you're going to add the behavior to like evict the least recently used. Okay.
Yeah. Okay.
So that's it. That's the put function. So now the get function, right? You're going to want to do like pretty much the same thing as you did. Just you need to find the key. And then if the key is there, you return it. Otherwise, return -1.
All right. To the value of key. The key exists. Oh, I just had -1. Find key.
So this time you're returning an integer.
Yeah, so return the value. Outside of here, we would return
Why did you? Why are you setting it
Oh
equal to
shit, I'm
value?
setting it. Whoops. My bad. My bad.
Okay, good. So this is like the most basic behavior that you need, right?
Yeah.
But this is not an LRU cache, right?
Yeah. Yeah.
So now you need to add that behavior.
And we did that. I mean, what it said earlier. I can't remember where I saw it, but with a linked list, right?
Right.
Okay.
So maybe just think about it then instead of just like reading the instructions. Like think about how you would do it.
Let's think about it. I'm gonna write this down here. What do we got here on the map? So in the beginning, the value of the key to exist. Um. Can we easily take the size of a linked list in C++? I can't really remember, to be honest. Or is that not possible other than iterating over the whole thing?
So what are you using for your linked list?
Well, actually, we wouldn't really need to do that. Actually, we could keep it the other way. I don't know. I'm kind of basically thinking about so obviously we have to keep the, so if we get an item, right, then we have to move it to the front being the most recently used item. So
Right.
I'm thinking with that idea there, we're obviously going to need a pointer at the beginning of the linked list somehow to be able to access the most recently used item. When we put an item in there, would we put the item into the insert the item into the other side of the linked list? I'm not sure. Would that be the most recently used item if we put it inside of the linked list? So would be also... I know at least we're going to need to have 2 pointers on the linked list. One pointing to the front and then one pointing to...
So, like, if you just... So, do you know about STD list?
Maybe. I don't know.
STD list is a linked list. So you can say like STD list push front, and that will push something to the front of the list.
Okay. Is there a push back? Or not?
Why would you want to push something to the back of the list?
Well, I don't know. I'm not sure. I didn't know. Maybe are we pushing new elements into the back of the linked list? I don't know. Are we pushing everything to the front when we're adding?
Well, whenever you add something, it becomes the most recently used.
Okay. Okay.
And items at the back of the list are the least recently used.
Okay. Okay. Okay, should I start by implementing the struct of the linked list, right? We need a node struct.
I was just telling you about STD linked list. Or STD list. That's a linked list.
Oh, okay. Okay, so we're not building our own. Okay. Alright.
But before thinking about the code, right? Like, do you understand the struct, like what you're gonna do with the code, like with the linked list?
No, yeah, I'm still trying to think about it. Like, not specifically, not fully understanding how exactly I'm going to implement it yet. No. Oh my god, dude. There goes my headset. Great, bro. Now I cannot hear you. Hang on. 1 second. I gotta charge it. Alright, bro. I cannot hear you at all. I don't have my headset on. So I'm just going to mute my mic. I'm going to think about it, but I'm going to see if I can figure it out. I'll let my headset charge maybe like, I don't know, half an hour or something. So. This is tough trying to think about this. STD list. Right from the beginning to the end. Okay. It's in place. So I feel like for the get, right? Well, maybe I guess we'd have to do the put function. Oh, doesn't really matter. I don't know. I feel like for the get function, we're gonna have to find the value that we're looking for. But the thing is, could we maybe look for an item that doesn't exist in our get? Okay, we can, right? So we can return -1, right? If I'm just not sure like how to think about it here. We have to get the item, move it to the front. I feel like, is there a way to easily move it to the front? In place front construction element in place at the beginning. Transfers elements from another list. You're gonna want to look at STD list splice. Oh shit. Well, big ears on the phone. This is a tough problem, bro. Not gonna lie, tough for me. Like, these are probably things I really need to work on anyway, so. Iterate a position, list other. Transfers elements from other to this. The elements are inside a position. Maybe the fine. Elements from other becomes. Transfer the elements from one list to another quickly. So we have two separate lists. You can also use STD list splice to move an element in the list from its position to the front or back. Okay. Put that in ChatGPT with a. Can you move element from? Can you move elements? Can you move an element from its position to the list using this splice? Oh, yeah, so you know. 1:2. To the front. Create the iterator, we find it. It's equal to list.end. List.begin, list, iterator. Okay, so you're right, so we can. So maybe, like, can we do if, trying to think about how we can do it with the hash map as well. Equal to m underscore items dot find key. And can we do like, I don't know if this works, to be honest. I'm not really 100% sure. If, can we then do like, if iterator is equal to, what do we have here? If it does not equal, if m underscore items. Here's the trick. I see. I see on the map. I see this. SC pay in m underscore LRE list. So you're saying copy and paste it into Leetcode so it's easy to read though. Yeah, I'm sorry, I don't I don't look at the comments on my computer. Hang on, let me take a look at this. SCD list. C pair int underscore value list. Whoops. No space here. Give it up here. Okay, unloaded map. We're passing in an int. Then an std list. Std list. Std pair int. underscore cache. Taking an integer and then std list pepe int iterator. I think I know what this means, but I want to make sure I know. Integer and the value type is an std list pepe. Pointing to an element inside std list of std pay. The list itself is not declared here, but this map stores iterators points to elements inside that list. Usage order. We have our list here, so what? M underscore this case dot find key if underscore find key is equal to the end. Alright, we can return -1. Right? So if we can't find it, then we know iterator is valid. So if the iterator is valid, what do we want to do? If we want to get that value, pointers. Oh, bro. You got this, man. Appreciate it, Llama, dude. This is fucking... I want to stick my head in a fan right now, bro. There is a pointers. To get the element, you can increment. Get the next element. Time to pass in the container. Does this work, Ethan? Like, is this valid? You have the iterator, you find it, right? If it's... Otherwise, if it's invalid, we return -1. Like, I guess we probably could have done it the same way, I guess. I mean, we were doing the same thing, I guess. I don't know why I really changed it, but... That's what do I have to think about here? We gotta move the item, right? Move the item, and then return the value of the key, right? Alright, to do that, we use .splice. Do I know how to use .splice? Line 12 is not valid code. Oh shit. Whoops, sorry, I didn't see that. I guess this is cache. I didn't change it. This is valid though. I think. Turn -1. Turn -1. Move the item with splice. I think we looked at that up here. Void splice. Can you move it to the position? This is not valid. Line underscore cache.end. Oh shit, wait. Sorry, that's what I meant. Yeah, shit, dude, I totally fucked that. Sorry, bro. Yeah. Okay, yeah, I don't know how it's, dude, sometimes sometimes I just don't notice things. I mean, I'm sure you probably noticed that about me. I just fucking I'm like thinking about it in my head, but then I realize I don't even fucking type it out on the screen. We return -1, right? So we want to move the item with splice. So now how the fuck do we move the item with splice? What do we have here to move it? We have an LRU list. We have a cache, right? So we'd have to move it in our LRU list. So at least now we know that the value is valid. We're going to return an SED pair, one being, I assume, the key value pair, right? Is what I think we talked about it down here. Yeah, our key value pair here, right? So stores dot splice. I gotta go back up to the splice function here. So what do they do here? So they list begin 30 if the array does not equal end list. If the array does not equal list end, list dot splice list begin list iterator. Position where you want to insert from. So move the item. So what do we want to do here? We want to go m underscore LRU list. M underscore LRU. That's what I call it, right? Yeah. Okay. Dot splice. We want to move to m underscore LRU dot splice. We want to move to the beginning, so LRU list dot begin. Then this is the source list, same as the destination. The source list. So what? M underscore LRU list. It is the iterator to the element you want to move. So what? This would be just it. I don't know if this is valid code. I think it is. I don't know. Thing is, I'm confused here. Do I want to move the item, the iterator to the element you want to move? But really here we're holding two elements here. Right, we're holding 42 and 100. But I guess what the iterator here is a pointer, I think. So return the value of the key. Because it is not a list iterator, it second is. Close. It is not a list iterator. It second is. Auto list it. So what, do I just go like it second here? And then I was thinking the same thing here, right? I'm gonna return it second, right? I'm getting confused what exactly the iterator is in this case. Like, I'm getting confused if it's a pointer, dude. I don't know how to fucking tell. Here it's not a pointer, but an iterator to the element found in unordered map. There's an iterator pointing to the element. This is where I'm getting confused. Pointing to the element of the given key found. The key is not found. It returns. The iterator is not found. It returns. Okay, I knew that. Yeah. Is the list iterator stored in the map? Yeah, it's second. Man, dude. Bro, this shit is driving me insane, dude. I feel like I'm not wrapping my head around it, like, fully. How is this different from a pointer? An iterator behaves similarly to a pointer. You can get the key value pair. Okay. You can access the members with it first, the key, and it second, the map value. So it second is the value. But isn't this function here? Like, why are we grabbing the second value here? Like, isn't the aren't we moving the entire node? Like, that's how I'm thinking about it in my head, right? Like, I don't know if I'm thinking about it wrong, but let's say, you know, we're removing this value, right? And this holds like 1030, right? Like, why are we grabbing the second value and moving the second value? Wouldn't 10 being the key? Oh, fuck. Wait. No. Wait, hang on. Are we removing... Answer your question by looking at what the map stores. Looking at what the map stores and what the list stores. Oh, okay. We got an SED list pair. Integer. So in this case here in our unordered map, this would be the second. And then we'd have to go second to get the value here. Right? Return it second. Okay, that makes sense. What's the key value pair? Yeah, you got it. An iterator to a map holds the key value pair as an STD pair. Okay, yeah, that's what I said. Okay. But what I'm confused about here, right, in this portion here, I guess I'm a little bit just confused with the splice function, you know. I get, you know, we're moving to the beginning, we're moving the LRU list, but why are we pointing to the second value here in... Wait, hang on. M underscore LRU, it's second. We have the iterator pointing to our cache, pointing to our second value. Okay, so we're moving, oh my god. Okay, so we're moving the whole pair here. Okay, I understand. I think I'm understanding here now. So that's why we're moving the second, right? What type is it? Yeah, okay. I think I understand now. Yeah. We're doing this. We're moving the it second because we're getting the entire SCD pair, right? And that's what we're moving. Right? That's it's the map iterator. Yeah, that's what I'm saying, right? That's why we're using the second here, right? Because we're getting the entire pair, right? The key and the iterator, right? Or the key and the... Is that? Yes, we're moving it, moving the whole iterator. Okay. So this is correct. Like, is this correct? Here? Is this good? We're going to need iterator and M underscore LRU list. Bruh. Okay, I want to fully think about this again. We're finding the key. If we don't find it, we return -1. If we do find it, we move our list, our linked list, or our list, SCD list, to the beginning from the current LR from our list that we have, and we're moving our second value in our iterator, and the iterator is looking at our hash map here, right? So we want to grab the SCD pair here, and that's what we want to move. Okay, that makes sense. And then we're returning the iterator.second.second. You need to fix the put. You need to fix put now. Okay, yeah. And we're returning our second, which would be our second integer here in our pair. Okay, so that makes sense. So now with our put method here, update the value of the key if the key exists. Otherwise, add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. Okay. Okay. We're gonna take this line by line here. We're not moving the list. We're moving the node in the list to the front of this. Yeah. That's what I meant. Okay. Thank you for clarifying. Let's think about this here. Right. So step 1. Right. Step 2. Sorry. Not very smart people like me have to step this out. I have not as much brain capacity to think about it. So update the value of the key if the key exists, right? So step 1, we need to check if the key exists, right? Step 2, if it does not exist, we add to the key value pair. Key value pair. Step 3, if the number of keys exceeds capacity, evict least recently used key. Evict least recently used key. Okay. How do we want to think about this? Step 1, check if the key exists. Okay, so how do we want to check if the key exists? Well, we probably want to check in our cache, right? So I guess we could probably do it the same way, right? We check if the key exists. So let's copy this. Check if key exists, right? Grabbing our iterator, finding the key. It is equal to m_cache.end. And what do we want to do? We want to, if it doesn't exist, what do we do here? Well, we need to return -1. Not in map. Check if exists. Do code force, sir. Have never really looked at code force, but thank you for that comment. Maybe I will. I don't know. I'm not really into competitive programming. I don't know. I'm not trying to be a competitive programming beast. Just trying to learn. How do we want to check no, not check if it exists, sorry, check capacity, right? So if it's not in our map, we need to check the capacity. How the fuck do we check the capacity? Well, if I don't get competitive programming. Yes, brother, you and me are the same. Hope you didn't forget me. Yes, brother, you and me the same. Hope you didn't forget me. No, bro, I didn't forget you. Sorry, I'm just trying to lock in on this, dude. How can we check the size of this hash map? Well, I think an unordered map has dot size, right? So I feel like we can do like, do we have to cast it to an integer though? I don't know, probably not. Maybe m_underscore cache dot size is equal to capacity. Okay, if it's equal to our capacity, we want to delete our least recently used node, right? How the fuck we delete least recently used node, right? I guess we can have an else here. We delete our least recently used node. How the fuck do we do that? I believe there's probably like a delete or something, right? Ice pop back, insert, clear, erases elements. Access the last element back. Do we get our last element using the back here? But is there a delete here? Is there a delete here, bro, in this SCD list or not? Removes elements satisfying specific criteria. Remove if. Void remove const reference, right? L dot remove 1. Okay, so I think we just need to remove here. So m_LU list dot pop back. Pop_back. m_LU list dot pop back. Okay, so I guess that find a point and save it as a stack. Then when hit other points, the stack will clear. Use it again. One, I guess, but it's clear stack questions. You need to ensure you remove it from the list in the map. Okay, yeah. Delete recently used node. I've never used SCD list. I have never used SCD list either, bro. I have never used it either. Pop back. If _cache is equal to capacity, we pop the back. Then we need to remove from our unloaded map. How do we remove an element from? Is there a simple map? Oh my gosh, dude. Erase. Okay, that's what it is. Removes the element with key banana. So when you pop back, you will invalidate the iterator in map. Okay. You will invalidate the iterator in the map. You need to cache it before the pop. Something like auto LRU keys equal to. Okay. C++ is confusing. Yes, sir. Yes, sir. It is. Yes, sir. Hang on, guys. My buddy's calling me. 1 second. Can I call you back in a little bit, bro? I'm fucking on stream right now, dude. You want to say hello to the stream? Hang on, let me put you on speaker.
I got some. You're gonna be freaking out, bro. It's just nuts.
Okay, alright, well, can I call you back in like, I don't know, half an hour or something maybe? Okay, type shit, bro. Alright, see you. Okay. Sorry guys, my buddy called me. Okay. So we want to cache the iterator here. So, okay. So auto LRU key is equal to m underscore LRU list. Can we use like dot back? Wait. Oh, you said dot back. Okay, that's what you said. I thought you said pop back. Okay, dot back. Dot first. Then we pop the back. Then we would go m underscore cache dot arrays LRU key. Okay, so I believe that works there. On a map, check capacity. We check if it's full. Okay, if it's not full, then we can just simply you need the key to the value iterator in your map. That's too many dot. Looks like black magic. Hang on guys, sorry, I gotta read this chat. Remove the bracket. What bracket are you talking about? Oh, you're talking about this. Oh shit, it's not a function. Yeah, okay. We're referring to the first value. Okay. Then we're talking about pop back, and then we erase our ORU key. You need the key to value iterator in your map. Also, first isn't a function, no bracket. Too many dot. Okay. So are you saying that this is incorrect here? M underscore cache dot arrays LRU key. I cached it here. The LRU list, right, is storing an integer, right? So then I'm erasing that key. So this should work, right? Or this looks good. Then we have the else here. This is correct. Okay, sweet. Okay. Is your headset charged? I'm gonna give it another 5 minutes and then I'll put it on. I think I can get this else here. So, okay, so if it's not equal to the capacity, m underscore cache size equal to capacity, we delete. Otherwise we can just delete. Okay, so we delete the least frequently used and map, and then we put in a new value. So put in new value, right? How do we want to put in the new value? Well, let's see here. I believe we have a push front, right? That's what we were talking about. M underscore LRU list dot push underscore. There isn't an else. Well, wouldn't there be an else if it's we're only checking the if here if it's equal to the size of the capacity. What if it's not? If it's less, then we just gotta add it, right? Or we just, I mean, I guess we can do it outside the if, but yeah, like still the same thing, I guess. But I guess we can get rid of this, but dot push. Doesn't push front only happen in DQ? This is the SCD list documentation, dude, so I guess it looks like it does. Push front inserts an element to the beginning, so push front, we want to push in our push front. How do we want to add this? the key exists. Are we just pushing like key value, dude? I don't know how to add this, dude, in C++. I don't know. I don't know what the. I don't know what the syntax is, dude. What is syntax here? CD what? Example? Oh, like this. Okay. Key value. Then we need to add it. The else would only add the value if the cache wasn't at capacity. Yeah, there you go, Tinley. Thank you for that, dude. I didn't know that off the top of my head. Okay. Now what do we want to do? We push the front, then we need to add to our map here, right? So we have our integer being a key, and then the iterator here. So oh my god, how would we add that? Or you always need to push the value. Oh, yep, you're right. Yeah, I'm fuck, dude. You are right. I'll do that here outside the if. You always need to push the value. Yes, sir, you're right. I was thinking about, I don't know why. I was literally thinking about doing it twice, so I don't know, that's so stupid of me, but yeah. Push the value. What do we want here? We want the let bro cook. I'm his teacher, dude. There you go, bro. Yeah, mind your business. Teach me C++, dude. Anyway, okay, push front, key value. Now we want to add it to the hash map here, right? So how the fuck do we do that? Okay, well, for starters, m_cache. I feel like we need some sort of like. I feel like maybe I'm overthinking it, but I guess it's throwing me off because guess what, the pair here, the FCD pair, cache key is equal to I don't know if this is right. Fuck, I'm missing a bunch of semicolons everywhere. Is it like this, dude? Or am I fucking tripping balls? Like m_key is equal to key value being our std list here, I think. Maybe, I don't know. Does this add a? We need the iterator that points to the front of the list. So you saying like the iterator that points to the front of the list returns an iterator at the beginning. Okay, so what do we maybe like call it like? There's probably a shitty value name. Value 2 is equal to m_lou list dot begin. Is that what I did? Is that what you mean? The iterator here? Dot begin value 2. I think. If we add capacity, evict least recently used item. I don't know what this is here. I don't believe this is. I think this is old code. Yeah, but you can just assign it directly instead of making the temp variable. Okay, yeah, that is true, yeah. True that. Okay. So we've got our size, right? So, okay, check if the key exists, right? So if our key doesn't exist here, so what if our key does exist? So if our key does exist, then we added to the key. So what do we do if it does exist? Update the value of the key if the key exists. So all we're doing here is updating our value here. So, and then moving it to the front. So I guess we have our else here. Well, what's the first step here? I'm thinking about it too much. So let's do some steps here, right? Step 1. What do we want to do? Well, we want to update the value of the key if the key exists. So the value of key if key exists. So, and then we need to, step 2, move to front. Grab your headset if it's charged. Okay. Okay. Yo, can you hear me, bro?
Yeah, I can hear you.
Okay, hang on. I don't know how long I have, but should be good. So I'm gonna update the value here of the key. If the key exists, move to the front, right? So okay, how we want to do that?
So remember that you have IT, right? So like if you scroll up, so
Okay,
if
we have the iterator here. Okay.
so here it's valid for sure, right? Because it doesn't equal the end.
Yeah. Update the value of the key. Okay. I have to think about this deeply, dude. I have to go. Okay, hang on. I'm such a slow thinker. Okay. So we want to probably update our map first, right? So score cage.key, right? So here, but instead we have the iterator here. So the iterator has dot, right? Dot first.
It's
First.
it's the arrow. So what are you trying to access?
The key.
The key. So yeah, it'd be second arrow first.
So you're saying double, right? Is that what you're saying? What am I looking at here? MSQL case, our iterator here is pointing to our cache. What is our cache holding?
Well, so you have the iterator. Go up. What is iterator? So that's the iterator to the map. So that's going to hold the key value pair in the map. So first is the int and second is the iterator. So you can just do it dot first, and you don't need the second first.
Okay. First, right? We grab the key is equal to what our value that we pass in, right? So
I mean, if you're just trying to get the iterator to the list iterator, you can just do it arrow second.
well, no, I'm trying to update our value here, right? So I want to grab the key and update it in our cache, right? So we update it to our new value that we pass in here. This is correct, right?
Well, so the way I would do
Oh my
it,
God, I just went
right?
back. No, dude, no. Oh my God, bro. Hang Dude, if my code's gone, I'm gonna be so pissed. Okay. Okay.
So the way that I would write it is I would just say, so instead of the like auto and then like list IT equals IT arrow second, because you're just trying to update, because the list iterator is what actually holds the value, right?
Right. So we already have access to it. So I don't have to do all this.
Exactly.
That's what you're saying, right?
Right, exactly.
So we say iterator second is equal to value.
Well, so
is this what you're saying?
Not quite. So the way, because okay, think about it. IT arrow second is giving you the list iterator, right?
Yeah. So
But
we set that
value-
second.
Yes, but I would just, you're gonna need it later, so you could just save it to a temporary variable. Like I would just, so it would help it make more sense to you. I feel like if you do like auto list IT equals IT second,
Okay.
and then get rid of like the equals value. And then now on the next line, you just do list IT arrow second.
Second is equal to value.
Yes, because then now this is how you're accessing the value technically on the list iterator.
Okay.
So,
updating that
but
key-
why are you gonna need the list iterator now?
Because we're gonna move it to the front.
Yeah, exactly.
So move to front. There's so many comments here to think about this. Oh my god. Okay, move to front. So what do we want to do here? We use our splicing here, right? So where's our code here? So m_LRU list dot splice. We pass in. We want to go to the beginning, so we would do m_LRU list dot begin. We'd pass in what list we're working on, and then our iterator here. And our iterator here would just be list IT. I believe that moves to the front too. And what do we return here? We want.
Well, so it just
void.
returns void.
So we just
So-
do return.
Well, you don't even need to type that, but yeah.
Yeah, I mean, I guess you're right. Fuck it, I'll just leave it. Oh my god, dude, I went back again. What the fuck?
Bro.
Oh my god. Okay. Alright. Let's run it for once, dude. I'm gonna have a bunch of errors, dude, but let's just... Okay, what's my first error here? Undeclared identifier capacity, did you mean? Yes, that's what I meant. Yes, sir. Okay.
I honestly think it's gonna work. Like after you fix all the syntax errors, I think the logic is sound.
Oh my god, dude. Let's go.
Let's go, dude.
Oh yeah, bro. Let's go. dude.
Let's go, bro. Let's go. Good job.
Oh my
And no, I mean, like that's a pretty difficult data structure to wrap your head around, especially like all the C++ syntax and stuff like that.
Yeah, dude, that was so frustrating, dude.
Do you understand it now?
I do, yeah. It just like, I don't know, man. It's like, I feel like these data structure problems are so much tougher for me to like think about. Like, you know, I'm not just like, you know, I feel like I have a lot of experience on like a lot of the other problems, but some of these design ones just like fucking throw me off. Like combining all these different things is like definitely pretty tough. So, bro, on this,
Yeah.
I would say just get to the editorial. I don't know what does that mean. Get to the editorial. Yeah. Okay. Sweet, dude. Let's
All right,
go,
but do
bro.
you understand it now? Like, should you walk through it one more time just to be sure?
Yeah, yeah.
Because this is honestly a useful data structure.
Yeah. Okay. Yeah, I can. So creating our map here, and we got our SED list here that hold 2 integers, right?
So, for like, really, what is an iterator? That's a good question.
what is an iterator? It's a pointer, or it's not a pointer. I was just looking it up in ChatGPT for like 5 minutes. You are king, dude. Thank you, bro. Appreciate it. An iterator.
It's just
I
an
know
object.
fundamentally kind of what it is. I mean, we're looping through all the values, but I don't specifically want to be able to communicate exactly what an iterator is. But I'm just thinking, I was going to say that it's just a pointer to, you know,
It's an object. It is basically a pointer, right? It's just an object that acts like a pointer that points to a specific element in a data structure.
right. Okay.
That is all it is.
Okay. Okay. So it's a. Let me re-say what you said. So it's a object that you can use to loop through a data structure that points to a specific spot in memory.
Right. So iterator is just like an object, right?
Yeah.
And its value corresponds to a specific element from a data structure.
Yeah. Okay.
And like you can say like iterator dot next, right? For example, and that would just take you to the next element until it's the end element.
Yeah. Okay. Okay. What's the use of this data structure? Well, what is the use of it? It's a least recently used cache, so we can get items, put items, and update them based on when they've been accessed.
Well, so like if you had a bunch of like data, like hot data, for example, that you wanted to process and keep stored somewhere, then you would use at least recently used cache, and like the most recently used data will always stay in the data structure. Essentially, it's just used for like memory constraints, usually.
Yeah.
Or like a hot cache.
Yeah. Getting the values, we're creating iterator here. We're checking, okay, well, if it gets to the end, where, you know, we haven't found something, we return -1, so it doesn't exist. Then here we move the item using splicing in our original list. We move the item to the beginning, and then we return the value of our key here. Then our put operation here, we're doing the same thing, creating our iterator here, looking for a specific key. If the iterator is not being found, so it's not inside the map, we check, okay, well, is the capacity full? If it is full, we delete the item here, and delete the item from our linked list as well as our hash map here, and then we put in our new value. Then we have our else statement here, which is if it is in the list, then we simply update our value and move it to the front for our least recently used item and return. So, yeah.
There we go.
Sweet. That was a good problem. It was very tough for me to think about it in the beginning, but it was. I think as I was breaking it down smaller and smaller and smaller into like simple steps, I started to like get the flow and was able to progress a little faster instead of like looking at the big picture. And I feel like for me that's like super important for me, like breaking it down like little by little. So it was good.
Yeah, I think you got it. Good job.
Yeah. I was planning on doing a little bit of project work, but I think I'm gonna end the stream there. I'm gonna call my buddy. So tomorrow I'm gonna continue working on the C++ project. I was gonna work on the other one today, but I think I'm going to call my buddy and work on the C++ stuff. So a little bit. So work on my game a little bit. So appreciate you guys watching. Thank you for watching me struggle. Probably thought I was an idiot at points, but I appreciate everyone watching, so thank you guys for your help, and I will see you guys tomorrow. Peace.